Welcome back, coders. Nice to see you. All right, so today, this lesson, we are going to be learning about integers and floats. Integers and floats. And you can see some examples over here. We're going to be learning about that. First thing I want to mention is that we're going to cover a lot of different concepts throughout this PowerPoint. Pay attention to them, but don't worry, we will cover them further during the coding portion of our lesson. But I will be introducing the vocabulary, particular vocabulary, and what the important points through the presentation, through the PowerPoint presentation. But then I will reinforce that knowledge through the coding session. All right, let's get started. Integers and floats. First comes an outline. First, I'm going to introduce basic number types. I'm going to introduce what numbers Python works with typically. I'm going to talk about arithmetic operations, what operations you can perform on those numbers. Type conversions, I will be explaining how you can convert, and you've seen this a little bit. If you've watched lesson 2, my previous video about strings, there I demonstrated type conversion a little bit while I was working with the strings. I introduced some numbers, and I demonstrated how you can use the type conversion. We'll be covering that more in depth in this lesson. Precision and rounding. Python's got some aspects of precision that it's not just Python, but coding. All programming languages have this precision problem. I'll cover that problem as well as how you can round numbers when you're dividing and whatnot. Actually, during the arithmetic operations portion over here, I have a complete slide just focused on division, because division can get, because of the remainders and the infinite decimals, they cause problems with the computation and mathematics on a computer, and so I will go into that as well. And then I will very briefly, introduce loops, in particular the if loop. Most of the time, most of the information will come from the coding session. During the presentation, I'm not going to really introduce it as much. And also, this is just going to be a brief introduction. Our next lesson, lesson 4, I believe, this is lesson 3. Lesson 4, you will be learning all about different loops. There's an if loop, there's a for loop, there's a while loop, bunch of loops. And we'll learn about them and how to use them, incorporating everything we learned about strings and what we will be learning about integers and floats today. After the if loop, we will start practicing what we learned through code. All right, let's get into it. Basic number types. First number type we're going to cover is integers. It's the simplest number. It's the whole numbers, 0, 1, 2. That's also the first set of numbers you learned about, 0, 1, through 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to infinity. All of those whole numbers are comprised of integers, including the negative numbers, negative 0, that doesn't make sense, but it is what it is. You got 0, negative 1, negative 2, negative 3. That's a little typo for me. Negative 4, all the way to infinity, going the other way, actually, going to the left, probably. That's how I like to think about it. With the 0 in the middle, to the left is the negative numbers, to the right is the positive numbers on the number line. All right, what about the numbers in between 0 and 1? What about those numbers? What are those considered? Those are considered floating point numbers. Yeah, it's shown as float. When Python tells you what type it is, it's going to output float. So that's floating point numbers. These are all all numbers that have a decimal point. They can be positive or negative, but if they have a decimal, then they are a floating point number. These are some examples. I have examples. 0.1254. I just came up with this random decimal. That's a floating point number. Negative 0.102. That's a floating point number. 4.4 with a decimal right here. You see? Oh, let's bring up the laser pointer. This point right here, that point, that means it's a float. That means it's a floating point number. 5,376.1 0, that's a float. So anything with a decimal point is a floating point. How does Python tell if a number is an integer or a float? If there's a decimal in the number, it's going to be a float. Otherwise, it'll be an integer. We're going to see more examples during the coding section. Section of our class. We're also going to be using the type function, which I introduced in the previous lesson, lesson 2. Again, we're going to be referencing lesson 2 a lot. So if you haven't seen lesson 2, um, I'm going to put a link in my description, and I will probably put a link at the end of this video about lesson 2. So you can watch this video all the way through, go back to lesson 2, watch that one through, and then come back to this, and you're like, oh, that's how that all looks up. So if you want to do that as well, or you can go down to the description and watch that video first, and then come back to this video. In that video, I introduced the type function, and I showed how it can identify an integer, or I think I introduced integers and floats there. Briefly introduced them. Today we're going to be learning all about them. All right, what about arithmetic operations? So you can add, subtract, multiply, divide. You can actually perform put in exponents. Multiply repeated multiplication exponents. So like x or let me see, 4 to the power of 3. You can do that. And you can actually find the remainders of division. So division actually, it's a little complicated with Python because of the floating point numbers. Because when you divide two numbers, the after the decimal, it's always infinite expansion. I'll explain more about that when I get to that section. All right, that'll come next slide. This slide, we're just going to be covering addition, subtraction, multiplication, and exponents. Division will come next slide. With Python, you can add numbers, which can result into added numbers, or you can add strings. So remember in previous lesson, again, I'm referencing the previous lesson. In the previous lesson, I introduced that you can concatenate strings by putting a plus in between them. So like you would type in hi, and then hi in quotation marks, and then you would put a plus, then you would put viewer in quotation marks, and then it would print out hi viewer. So that's what concatenation is. If you don't know what it is, go back to lesson 2. So I introduced that in lesson 2, but here you can add numbers. Subtraction is the opposite of addition, and you'll see all this during the coding section. Subtraction is the opposite of addition, but you can't subtract strings. So bummer about that. You can multiply numbers using the symbol within the parentheses. In this case, it's a little asterisk mark, that little star. It's if you press shift and then 8, shift 8, that's how you're going to get this symbol. And it's also possible to multiply a string with a number. And I think I did that in the last session as well, if I remember correctly. Yeah, I think I did that in lesson 2. All right. And then last, you can use this symbol, two asterisks, asterisks. I'm not sure how to say that plural. If you so essentially press Shift 8, then that's how you denote an exponent. We'll see that during the lecture, during the coding section. Now let's get to division. Division's more complicated because it's going to result actually in 3 different outputs, depending on how you type it in. First is the standard division. This you're going to use the slash symbol, and this is used to perform standard division, which will result in the following answer. Which will result in the answer to the question. So like 20 divided by 5, that's going to result in 4.0. This is going to be really important because it's going to result in a floating point number. So in this case, 20 divided by 5, 5 times 1 equals 20. That's going to be 4. But it's not. But in Python, when you're dividing a number, the result is always a floating point. So it's going to be 4.0. I'll put 4.0. And we'll see that during the coding section. 3 divided by 4, that's going to be 0.75. 22 divided by 7, that's standard fractional representation of pi. It's not pi, it's just a 3.14, and then it has another random infinite expansion after that. But not infinite. Oh yeah, I guess it is infinite. After that, but it's just 3.14. And there's a better representation of the pi, but I just put that there because I thought it would be fun little reference. And then 1 divided by 3, that's gonna be 0.3333333 infinitely. All right, that could cause problems. So we'll talk about that in a little bit. But yeah, as I bolded over here, the answer is always going to be a floating point. Even if it's simple, like 20 divided by 5, it's going to be a floating point number. If you use the double slash, 2 slashes, um, then the result's going to be an integer, the integer of the division operation. So 20 divided by 5, if you do double slashes, it's still going to be 4. Great. But um, and, but what's the benefit here? In this case, like if you divide 7 divided by 2, that's going to be 3.5, right? But if you divide it using the double slashes, it's not going to be 3.5. It's going to be 3 instead of 3.5. It's going to be 3, just the integer part of the division. So you remove the decimal part. All right. If you want to find the remainder of a division, so in this case, you can find the integer part and then the remainder, like we did when we were learning how to divide in like third. I think I learned in third grade or fourth grade. I don't remember. But when I learned first, before we got into decimals, we got into remainders. We found the integer, then we found the remainder of the division. This is what you can do with Python. You can find the integer using this double slashes, and then you can find the remainder using this symbol right here. It's a percent symbol, but it's also called the modulus. The modulus. That's a new word you might not have heard about before. It's a word that's used in mathematics, actually. Yeah, this function is used in mathematics. So yeah, you're learning more about math through Python. Anyways, it results in the remainder. So in this case, 7 divided by 2. 7 doesn't divide evenly into 2. It's 6 and then plus a remainder of 1. So it's going to output the number 1 as the answer. So it's going to output the remainder of that division. 7 divided by 2, the remainder is going to be 1. So that's what's going to be output if you plug this into the Python. We're going to be using Google Colab for our Python programming. So you can follow along using Google Colab as well. So I figured I'd show you that way. Next, we're going to go into type conversion. So as you, going back over here, going back to division. As you can see, division is kind of complicated because of the decimal expansion. We're going to actually cover more about the decimal expansion problems associated with that in like 2 slides. After I think it comes after the type conversion. All right, going back to type conversion. Okay, so you can use and I introduced this again in my previous lesson. I use the this function int to convert a string into an integer. That's what I did last lesson. I converted. I think the string I converted is, I don't know. I feel like it was number 4. I'm not sure. I haven't seen that. I haven't seen it recently. But I converted the string that we imported into the Python, and it imports as a string, and I converted that into an integer, so we can then multiply it with another number. We'll go back to lesson 2, and you can check that out. Or if you use float, you can convert that number into a float, or a string into float as well. If you want to float, you'll use float. You'll use float function. If you want to convert it into an integer, you'll use int. We'll look at that more during the coding section. Examples. Integer. You say int, and then in parentheses, then you put in the arithmetic equation or arithmetic function inside the parentheses. So in this case, int 8 divided by 4, that's going to output 2. And it'll make sure that it's going to be a 2 and not a 2.0. And then float 7 times 4. In this case, 7 times 4 is 14. Instead of outputting the integer 14, it'll output the float 14. So it'll output 14.0. Another example is over here. This is more similar to what we did during lesson 2, where we converted the input, uh, where you're asking what's your favorite number. You're going to put in a number. That number is going to be interpreted by Python as initially being a string. You have to specify that it's an integer using this int function in order to perform math with it. All right. You can't convert a decimal into an integer. That's the only problem. You can't convert a decimal into an integer. That'll result in a type error, I think. An example, int 3.5. That won't work. It will not work. So that's we'll cover that during the lecture. During the coding section. Precision. Now we get into more division and addition and more about decimals. In Python, 0.1 plus 0.2 doesn't actually equal 0.3. And I'll prove that to you during the coding section. 0.1 plus 0.2 doesn't equal 0.3. This is because computers use zeros and ones, on and off. It uses base 2 number system. All right, this is really important because the numbers 0.1 and 0.2 in the base 2 number system result in an infinite expansion. It's an infinite number of zeros and ones to denote 0.1 and 0.2. Yeah, this is a fun of math and fun of base the base number systems. We work with base 10 in our mathematics, but computers work with base 2 because that's all they understand is base 2, and that causes this problem. Python allocates a fixed number of bits to store memory. The computer's memory is not infinite. You know, you can't store 1.0000000 infinitely because the memory is not infinite. So it cuts the number at some point, at some number of bits. So essentially, this leads to 0.1 plus 0.2, resulting in, or it equals 0.30, 0.3000000000000004. Where did that 4 come from? That's exactly right. It came from nowhere. That's essentially how Python works. It's just how it works. And actually, this is how not just Python works. This is how all programming languages work. C++, Java, C Sharp, all programming languages work similar to this in that they just come up with a random number at some point after the decimal point, because they don't go infinitely, right? And so in this case, it'll have a 4 at the end. Why? Who knows? I don't know that. But either way, 0.3 with all those four zeros and then a 4, it's not exactly equal to 0.3. And so we'll explore that more in the coding section. I'll prove to you that it's not equal to 0.3. So this can cause problems. So you have to keep this in mind when you're programming, when you're doing some math on Python. Or on a calculator. Even your calculator will have this problem as well. But usually in the calculator, they don't display more than 10 zeros or 10 decimal points after the 0. That's why they cut it off, because they don't want you to see this part over here. All computers work this way. All right. When Python outputs the result of a division, it rounds the answer. When any computer outputs the result of a division, it cuts the answer at some point. It doesn't round the answer, but it cuts it at some point. However, we can round. We can do rounding ourselves using Python. You can round the answer up or down using Python. So you would use the round function to round numbers. In this case, Python rounds the digit to the right of the decimal point. If the digit to the right of the decimal point is 5 or greater, it'll round it up. So example, 4.5125, it'll round it to 5, right? It'll round it to 5 because it rounds up. So if you want to do some rounding, you can just use this round function. However, if you prefer to round down when there's a 5 right after the decimal point, which you can do, some people prefer to do that when they're doing math. Then you can use then you're gonna have to use a module, and we'll get into more modules um, in future classes. This is gonna be just an introduction into modules. I think in like 2 or 3 classes we'll talk about modules. There's a particular module called math, and we'll see this during the coding section. And in this with this module called math, you would use math.floor. Math.floor will mean you're gonna round down. You're gonna round it down. Or math.ceiling, which means round up as is typically done. Math. This is ceil is short for ceiling, and floor is just floor. All right. We're gonna explore this modules more in future classes. Then the if loop. This is just an introduction into if loops, a teaser for the next lesson, when we're going to explore these further. All right. During the coding sections, mostly when you're going to be learning about these if loops. But here's an example. If if a variable x, if x is less than 4, you're going to print x. That's an example of an if loop. Um, we'll explain more during the coding section. It'll make more sense then. Whew, that was a lot. Don't worry. We're going to repeat everything you learned through our coding portion of the video. So let's get started. Let's go already. If you know that reference, who can tell me what this reference is? Put it in the comments. Let me know. All right. I'll be back with you when I pull up Google Colab. Give me 1 second. Welcome back, guys. All right. So here you see lesson 3, integers and floats. All right. Here we are going to be learning about um, arithmetic operations first. So let's do that. I have some commented out codes. You can tell that with the hashtag. These are commented out, meaning that they won't run. If I run the code, nothing runs. Wait for it. It's connecting. There it goes. Connected, nothing runs. Obviously, because we haven't output anything. We haven't typed anything. So let's do it. Let's say print. We're going to print. You always need a print if you're going to print something to the console. You need to use the print function. If you don't, with Google Colab, you can do this. You can just type in 4 plus 5. You can type that in and then run the function. It'll output 9. However, if you want to output that and you want to output 5 times 9, it won't output both because it'll only output the last one. In order to avoid that happening, and also for standard practice, when you're going to output something to the console, you are going to need to use a print function, which I introduced in the last lesson. All right, so go away. A print function. All right, so what we're gonna do here is we're gonna do some mathematic operations. As you saw, I just introduced a little bit of mathematic operations. Let's go with 2 plus 3. All right, we're gonna output 2 plus 3, which I think you guys already know what it equals. It's gonna equal 2 plus 3. It'll equal 5, obviously. All right, that's what we're gonna print. No, I don't want to do that. That's the problem with the Google Colab. It's trying to be helpful by predicting what you're gonna output, but I'm not gonna output that. So I'm just coming up. Stop it. I wish I could make it stop. I don't like that. But it can help you out if you are coding repetitive stuff. It'll help you out that way. All right. Next, we're gonna do 2 times 3. Let's do 2 times 3. That one's gonna output. We're gonna see if it's gonna work. 2 times 3 is gonna be 6. Let's just get rid of this equals. All right, and then we're gonna do print. Let's go with 5 minus 2. That's going to equal then we're gonna print. Let's see what minus 2. We're gonna do let's do the same way. Position 8 4. That. Well, output will output 2. Wait, actually, 2. Output 2.0. You'll see that. And then when you print, we're going to do 2 squared. Let's do 2 third part. Third part. That's going to equal. That's going to equal, that would be 2, 4, 8. That would be 8. Then, let's print. Let's do 8 divided by 2. 4. No, let's do 2. All right. Do you remember what that, what is that symbol? Do you remember what that symbol is? I hope you do. That symbol is the integer division that outputs the integer only, not the decimal. All right, that's the integer division symbol. And then last we're gonna do print. Yeah, that's exactly what I want. The modulus. 8 divided by 2, but the modulus, which is gonna be 0. All right, so let's do that. Let's prove to you that this works. Let's run it. So first one, 2 plus 0, or sorry, 2 plus 3, that's 5. And then we have 2 times 3 is 6. Then we have over here is 3, is 5 minus 2. Then we have 8 divided by 4, which is 2.0, like I stated. 2 times 2 times 2 times 2, or 2 to the third power, that is 8. 8, the integer division of 8 divided by 2 is 4. It's not 4.0, it's 4. And then 8 modulus 2 is 0, because the remainder is 0. There's no remainder. If we do 3, in this case we're going to have a remainder of 2. You see that? So that's how these arithmetic operations work. So 8 divided by 3 is 2. All right, cool. So now let's actually silence all that stuff, because it's not. Let's just put the actual answer there. All right. Next, we're gonna look into type conversion. So 8 divided by 3 is 2. Let's go with 8 divided by 4. So that one is 2.0. That one I put 2.0. So let's go with print. We put 8 divided by 4. All right. Run that. It's 2.0. You see that right there. However, what if we instead we're gonna put that? Or sorry, not that. We're gonna put this guy. Put it inside parentheses. Then we're gonna put an int. If we put int in front of it, that should convert 8 divided by 4 into an integer. So we're gonna run that. Boom, we got an integer 2. All right, how do we know that it's an integer? We can use the type function. Print type int 8 divided by 4. All right. So what is this gonna do? This function right here, this type. If we hover over it, it'll tell you what it does. No, it actually doesn't tell you. What it does is it tells you what the data tells you the data type of the output of the output. All right. So in this case, we can figure out what's the data type of that too. In this case, and if it right there, it outputs int. So that means it's an integer. All right. What if we get rid of this int part? We're gonna get rid of that one. We're gonna get rid of that. We're gonna get rid of that, and we don't need that one either. So we'll run that. This 8 divided by 4, we're just gonna run it without the integer. Now it's a float. Without the type conversion, it's just a float. In order to have it be an integer, you have to put in this int in order to convert it into an integer. This is useful, especially with division if you want just an integer. Let's try something else. Let's try something. Let's do something fun. Print 7 divided by 2. So that's going to be 3.5. Let's silence this stuff. All right, let's just do that. That should be 3.5. Yes, it is. All right. Then we're gonna do something different. We're gonna say we're gonna copy the paste this. Actually, we're gonna copy paste this down here. But instead over here, what we're gonna do is we're gonna convert that into an int, and let's see what happens here. So it should still output 3.5 because I haven't changed anything there. Again, Python reads left to right, top to bottom. So it'll print this one first. It'll print correctly, but this one, what's going to happen there? Let's find out. Oh, interesting. It just gives you the integer part of the division. It just gives you the 3. So this is kind of what I want you guys to do with this for homework. I want you guys to play around with Python and see how Python handles with these numbers. In this case, I didn't know what was going to happen, so I figured I would try it out. All right. So in this case, it converted this into just the number itself. So the other way you can do that is to do this function right here. So this is the same thing as essentially doing this. Same thing. And what is this called? Do you remember that? This is oh, it's up there. Integer division. So this is the same thing. It just divides it and gives you the integer. So what about the remainder? Let's find the remainder of it. Print 7. I don't know what it told me. It must have told me something. But 2, it must have auto generated something. But my eyes were off it. Anyways, 7 modulus 2, that will give us the remainder, which is 1. Good stuff. That's fantastic. That's exactly what I wanted to see. And then yeah, I went over the type function. I went over integer conversions. Oh, one more thing. Print 4. But we're gonna make that into a float. I don't think I've ever needed to do this, but you can. So let's try and see what it outputs. Oh, look at that, 4.0. Now it made the number 4, the integer 4, into 4.0. All right, that's enough of that. So now this coding section is not going to be too long. All right, now I got what are these symbols I have over here? 2 equal signs and an exclamation point and an equal sign. What the heck is that? This is how these are used for Boolean functions for Boolean functions within Python. So, for example, you can say print. I'll put this to the console, so I have to print. We're gonna say is 3 equal to 3. So this is essentially saying is 3 equal to 3. A Boolean function outputs either true or false. It's always true or false. In this case, you're asking is 3 equal to 3 when you use the double equal signs. And in this case, if we print it, it's gonna output true, obviously. How about we do another one? Print is 2 not equal to 4. So in this case, the exclamation, I'm gonna space this out so it's a little clearer for you guys to see. No, go away, not you. I'm trying to go up here. Is 2 not equal to 4? So that's what that means. Is 2 not equal to 4? In that case, it's true. If 2 is not equal to 4. All right. So that's how you code not equal to and equal to. This is going to be really important for loops. When you're getting into loops, for loops, while loops, if loops, sometimes you will need to use these Boolean operators. There are other ones. So you can say, I'm actually going to introduce those as well. Print is 4. Let's use a different number. Let's go with 23 is that greater than 2 or 1? Is it greater than 1? So that's another Boolean operator. That one's going to output either yes or no, or true or false. It outputs true. It is, because it is true. Right now I'm just giving you true ones. Let's change this to a less than symbol. Now it outputs false. 23 is not less than 1. 23 is not less than 1, so it's a false. All right. And then, so you saw greater than and less than, but you can also do print greater than or equal to. Print is 4 greater than or equal to 5. Is 4 greater than or equal to 5? In this case, it's not, so it's false. Is it greater than or equal to 3? Yes, it is. It's true. Is it greater than or equal to 4? It is true. How about, is 23 less than 23? That's still false. Is it less than or equal to 23? There, it's true. So you can see these are important functions. These will be really important as you progress through Python. Very important. I use them all the time. I use these functions, especially equals equals. This one and this one are two of my favorite expressions within Python, and these are used with the if loop, which I'll introduce at the end. All right, we're almost there. We are going to go into now the problem of here, and we're going to prove to you that these are not equal. So here you see the equal equal. You see the Boolean operator here. So in this case, what we have is, so let's just print it as it is. Print 0.1 plus 0.2 equals 0.3. And let's see. If it outputs true, then we know that they're equal, and I was totally BSing everything. But if it outputs false, then you'll be like, what? Why is that? And I'll tell you. I'll bring back the PowerPoint and show you why that's the case. Wait, actually, let's get rid of this. Let's come out all of that just so it's clear. Output's false. Look at that. It's false. 0.1 plus 0.2 does not equal 0.3. Wait a minute. That doesn't make sense. What about, so what is 0.1 plus 0.2 equal? Let's see. Print 0.1 plus 0.2. Wait, 0.02. 0.2. All right, let's do that. Run that. Look at that. That's what it equals. 0.3000004. That's obviously not equal to 3. Print 0.3. These two are not equal. So that's why this output's false. So let's bring that back. That's why it's false. So yeah, again, this is because of the base 2 operations within the computer. How the computer works. All right. That's just how it is. All right. Last, we got the if loop. We're going to introduce the if loop. So let's introduce a variable. Remember, I spoke about variables in last lesson. Let's introduce a variable now. We're going to introduce viewer as a variable. Viewer. We're going to make it equal to a number. We're going to make it equal to 76. Ever played Fallout 76? We're going to make it equal to 76. All right, viewer is equal to 76. Let's say. So now we're going to put in an if loop. If viewer greater or equal to 5, print uh, print you are awesome. Share this video with another person. Share with others. No, you are awesome. Please like, subscribe, and share this video. Help support my channel. All right, and then we're gonna. There's a problem with what I just wrote over here. Viewer equals 76, and then say if viewer is greater than or equal to 5. 76 is never going to change, so it's going to be greater or equal to 5. So in this case, if I run this code, it'll print infinitely, and I'm going to have to stop the code. We have to put a way uh, to stop the code, to stop the loop. So this is the problem with these loops. These loops iterate all the time. So while it's greater than or equal to 5, it will constantly go back and forth. It will constantly be running this code. That's the thing with these loops. They can run forever. We're gonna say viewer equals viewer minus let's go with -5. So that way it'll stop faster. All right. Viewer equals viewer minus 5. In this case, every time it prints you are awesome, please like and subscribe and share this video, help support my channel. Every time it prints that, it's gonna, right after it prints it, it's gonna subtract 5 from viewer up here. All right, it's gonna subtract 5 from viewer. There's an easier way to write this down. So we're actually gonna use the easier way because that's the way I like to do it. It takes up less lines of code. This is the same thing as viewer I had this spelled right. Minus equal 5. These two are exactly the same. This one is just a lot shorter and easier to code. All right, let's run it and let's see what it outputs. Boom. Wait, what happened here? It should have outputted many more times than that. Wait. Oh, what the heck is going on here? Oh, I was wrong. I was wrong, guys. I thought we were using a while loop. If loop just runs once, while runs many times. Sorry, I make mistakes too. I'm not perfect. I'm coming up with this stuff on the spot. Let's change it to while. This is another. That was the if loop. In this case, if was true, and if it was true, so then I'll put the answer. But while will iterate multiple times. So while, you can see multiple times, but it did stop. It did stop because of this. Viewer minus equal 5. It um it subtracted 5 from 76. And every time it subtracted 5, up until it was less than or equal to 5, or less than 5. And when it was less than 5, then that's when it stopped. All right, let's bring it back to if. My bad, guys. I was wrong, but either way, it works. So that's essentially a little bit of introduction about if loops. I will introduce more next class. All right, stay tuned, subscribe, all that fun jazz. While editing this video, I totally forgot. I have a challenge for you guys. My challenge for you guys is to generate some code to average 3 numbers, and I'm gonna show you my method of fulfilling that challenge. However, I want you guys to do it on your own computer. I want you guys to generate your own unique code. And if you want, you can comment and share your code on the comment section. I'll share my code in the comment section so you can see that as well, and you can see how to demonstrate how to do that yourself. All right. So let's do this so let's fulfill this challenge. All right. We're gonna call this coding challenge. All right. There we go. So, yeah. All right. So let's see. I want to generate code that takes a user's input. The user will input three numbers, and I'm going to take the average. So that's what I want you to do. Take the average of three numbers. That's what I want you to do. That's what I'm going to do. I'm going to say right, input, and then we're going to say. All right, there's my code. Sorry, I had to do a lot of revisions there. I was coming up with what I was going to write while I was writing it, so that's why I went back and forth and copy pasted and all that stuff. Anyways, this is what I came up with. First, it's gonna print out. Think of your three most favorite numbers. Then it's gonna print out. What's your first favorite number? And then you write that number. What's the second favorite number? Write that number. Third favorite number? Write that number. Then it's gonna print the average of all three numbers. Here, I did something a little bit different. Here, when you include an F right here, this is format. The F stands for format, I think, and I'm not sure what the F stands for. I just know how to code this stuff. Uh, so you put an F, then you can put a variable. In this case, I have the variables X, Y, and Z. I have those variables. As long as you have these brackets, that'll denote the variable. And so this is another way. This is the same way as this is the same thing as printing. It's the same thing as printing this. This is how you know how to print a variable or a string and then a variable. If you saw my last video, this this is the way I prefer printing strings and variables, by just printing them all within the quotation marks. You can use whichever method you want. Anyways, so if we run this code, we can check it out. Think of your most favorite numbers. All right. What's your first? What is your favoriteest number? My favoriteest number is 4. What is the second number you thought of? Oh, I didn't think about any of the numbers. Let's think about a number. 76. Why not? And then what's last the last number you thought of? Let's come up with a number. 1,003. Let's plug in numbers. All right, there we go. That's the number. Enter. Boom. Oh no. Oh, error. Okay, give me a sec, and you'll probably encounter errors too when you're running your code. Um, Here's the problem. So what I can do is put an int in front of this. Oh, oh, all of that divided by 3. And that should give the right answer. That's it. Let's try it out. 76, 13. There we go. That's how we do it. What? Yes, that's how you do it. Um, the reason is it was adding them all up as strings and then dividing it by 3. Um, yeah. Anyways, I think that's what it was doing. I'm not sure, but anyways, I didn't really want to figure out what I was doing. I wanted to figure out how to fix it, and so I had to convert each one of these variables, which input as when you input something, you're inputting it as a string. So I needed to change each one of those strings into an integer, and now I can add all the integers. Then after adding them all, I had to put them in parentheses, so I could say add these first and then divide them by 3. Order of operations, parentheses, PEMDAS, and then divide by 3, and then that's the average, 3.10. Fantastic, good stuff. So 31 is my average favorite number, apparently. So this is similar to what I want you guys to do it. I don't want you guys to do it the same way I did it. If you want, you can start out the same way I did it, and then you can come up with your own unique way. Um, I'll also introduce. I want to introduce so many things to you, but we need to take this one step at a time. Anyways, that's it. Have fun. Good luck on your coding challenge, and I'm anxious to see what you guys do, what you guys come up with. All right, I'll see you guys. Bye.